Today we are joined by Jack Silver, application chemist. With that, I would like to turn it over to Jack.
Hello, and thank you for attending this webinar about flash focus gradients in a flash. Today, we will talk about method development for flash chromatography. The techniques are similar to HPLC method development, and HPLC reverse phase methods can easily be transferred to flash columns. We will talk about a new way to develop both normal and reverse phase methods for flash chromatography that doesn't need TLC plates, and finish with a way to use silica solid load cartridges for reverse phase column loading. TLC plates are commonly used for normal phase method development, most commonly with silica gel. Once a method has been developed on TLC, it is easily transferred to a flash column. The elution time from a column is determined from the TLC retention factor called RF. The elution time in column volumes is the inverse of the RF. A column volume is the space left in the column after it is filled with the column packing. It is similar to the void volume in HPLC. A good RF for good column method development should be 0.5 or smaller. As an example, 0.2 is elution in 5 column volumes. One disadvantage of TLC plates is that people cause the compound to be purified to have an RF greater than 0.5 or 2 column volumes. The compound elutes very early in this solvent system, and there is little resolution from impurities. We use column volumes as a unit of measurement because it is universal. The elution time in CV is largely unaffected by flow rate and is the same value for both large and small columns. While silica TLC plates are very common in labs, other media are not so readily available, such as alumina, C8, C18, C18AQ, and amine, so method development is difficult for these media using TLC plates. The TLC chamber should be completely sealed so no vapor can leak out, and time should be allotted to allow the solvent vapors to saturate the chamber. In this slide, the 2 plates on the left were run without allowing the chamber to saturate and gave incorrect retention for the sample. The slide on the right was run after saturating the chamber and gave retention data that matched the column retention. Some samples don't appear under UV light on the TLC plate and so need to be visualized with spray reagents. This means a safe enclosure needs to be maintained for plate spraying. While most TLC plates show similar retention profiles, some plates give very different results and make it difficult to develop flash methods. Teledyne ISCO universal test mix run in 50% ethyl acetate and hexanes, with the second compound eluting in just under 4 column volumes, which match the column elution using Teledyne TLC plates. Other TLC plates don't match column retention very well. Other issues with TLC plates include the binder that keeps the silica attached to the plate dissolving in very polar solvents, and reverse phase plates often need a long time to run, especially in polar solvent systems. It is common that several trials are needed to make a good method to convert to chromatography, so several TLC plates need to be run, which takes time. For reverse phase, chemists commonly use analytical HPLC to develop methods. The runs can be fast, particularly for UHPLC, and need only a little sample for each run. Although each run may be fast, a trial and error process means method development may still take some time. You should determine the column volume of the analytical column and transfer the gradient method in CV to your flash column, as described in Application Note 118 on the Teledyne ISCO website. This works best with matching columns, as will be demonstrated later. Teledyne ISCO analytical columns have the same selectivity as Teledyne ISCO preparative and flash columns and allow the best method development and best method transfer. Now I'll talk about various ways to calculate a gradient. But why would someone want to do this? A single scouting gradient allows chemists to determine whether a compound will elute using a column and solvent system, and whether solvent modifiers such as triethylamine or trifluoroacetic acid are needed. A scouting run indicates whether a compound can be purified with a flash column or whether HPLC is needed, and also a user can estimate how much sample they can load on a column. The instrument detector is used to find compounds. The pure ion mass spectrometer allows positive correlation of the chromatography peak containing the desired compound. Evaporative light scattering detectors allow detection of compounds that do not absorb light. Here is an example where a scouting run would be useful. A 4-gram silica column shouldn't need 45 minutes to run. The user kept adjusting the gradient during the run because they weren't sure what solvent conditions would elute the compound. The compound eventually did elute, but after a very long time. Here is another example where time was wasted purifying a compound. Calculated gradients improve resolution and save time, solvent, and money. Because reverse phase method development takes so long, there have been attempts to make it faster. One method divides the scouting gradient into zones, where each zone is the preparative column gradient range. One disadvantage of this method is the time needed to establish those zones, which are different for different analytical and preparative systems. Another disadvantage is that the zones are not optimized for any compound. These compounds will elute late in the preparative gradient, and the gradient may end before the compound is fully eluted if there is any peak tailing. While this compound will elute early with little resolution from early eluting compounds. A newer method is the time on target algorithm. Like other methods, the desired retention is determined with an isocratic run using a model compound. The apparent gradient delay from the program gradient is determined by defining the elution time for a model compound as being the same solvent composition as used in the isocratic run. The difference in time between the program gradient and the elution of the calibration compound, the apparent gradient delay, is applied to other peaks of interest in analytical runs to determine the solvent composition that elutes those compounds. Changing the scouting gradient or instrument is easily done, as the new scouting gradient is simply run again with the model compound and the new apparent gradient delay is determined. PeakTrack has calibrated scouting gradients programmed for ReadySep columns. The runtime for these scouting gradients take the same time as a single TLC plate. As little as 1 milligram of compound is needed. This example was run on a 4-gram column and allows calculated gradients on larger columns. The focus gradient can be determined from the scouting run on a small column so that method development and scale-up are done at the same time. The scouting run on the previous slide was used to create both of these runs. The compound of interest elutes at the same time in CVs, although the column sizes are different. Reverse phase such as C8, C18AQ, or plain C18 can be run in the same fashion as silica columns. A scouting gradient is run, which typically needs the same time as a silica TLC plate. A focused gradient is calculated in the same way as silica. Columns such as alumina and amine can also be run in the same fashion. This technique allows flash method development for columns that don't have matching TLC plate, or the TLC plate is very slow to run. Here is a reverse phase study with a real compound. It is a large peptide. The scouting runs were run on the NextGen because the user didn't have analytical C18AQ or C8 columns that matched the Teledyne ISCO columns. As this is a large molecule, 15 milligrams or 0.002 millimoles was run. Although 15 milligrams seems like a large amount of material, this is a large molecule. Keep in mind that running a small molecule with a molecular weight of 300, 1 milligram has more molecules, 0.003 millimoles, than 15 milligrams of this peptide. 3 different reverse phase columns were tested, and a pure ion mass spectrometer was used to detect the peptides. The C8 column showed the best resolution from impurities, seen as a shoulder in the bottom run, and so this column chemistry was used for purification. The scouting runs allowed very rapid column screening. Also note that the different column chemistries showed differences in behavior, so a scouting run was needed for each of them. The time on target was focused on the second resolved peak on the C8 column and run on a 50-gram C8 column with a 300 milligram load. This is a large load for a similarly sized HPLC column that would be 20 by 150 millimeters. As on the scouting run, the mass spectrometer was used to detect one of the multiply charged ions, and 2 fractions were collected. The flash column cleaned the peptide very well. The runs are analytical C18, and the top chromatograph shows the crude mixture. The middle run shows fraction 1 from the 40-gram run, and it looks similar to the crude material, except that the last diluting peak is missing, and the bottom chromatograph shows fraction 2 eluted the peptide very cleanly. PeakTrack has calibrated focus gradients and allows easy calibration to analytical systems for reverse phase analytical systems. First, load the column and select the column from the list. Select the scout run from the choice of methods. This allows fast and easy scouting runs and method development for silica, C18, C18AQ, C8, and amine columns. To test small samples, use the method editor to change the detector sensitivity to 3 times or more. You may use ELSD or mass spectrometer if your system has these options. After pressing the Start button in the main screen, the Run Requirement screen appears. If using a solid load cartridge, use a 5-gram cartridge containing 0.5 gram or less of silica. For liquid injections, use a small injection volume. 0.1 mils is good for a 4-gram column. Do not use injection option none on column because equilibration is important to calculating a good run from the scouting gradient. Verify a collection rack is in place and the eluted compounds can be collected if desired. Press OK to start the run. After the scout run is finished, press the focus button. Select the column and loading type. If you put a different column in the system before getting to the screen, the system will select the new column. The new column should be the same chemistry as the one used in the scouting run. For example, if you ran a ReadySep RF gold silica column for your scout, you should use an RF gold silica column for your prep run. You can zoom in on the peak representing the desired compound, touch the screen and move a red line over the desired peak, and if needed, enter the amount of silica used in the solid load cartridge. Press the focus button to calculate a focused gradient for your compound. Remember to change the detector gain back to its original setting if the preparative run has a higher loading, and run the sample with the new gradient. It is very easy to use an analytical reverse phase liquid chromatography system. Using an analytical scouting run uses little sample and allows fast method development. To calibrate the analytical system, open the configuration menu item and then press the Calibrate External HPLC button at the bottom of the configuration window. Run your scouting gradient with Teledyne ISCO Universal Test Mix. After running the scouting gradient, enter the parameters in the Calibrate External HPLC screen. Enter the solvent composition used at the start and end of the scouting gradient. Also enter the gradient length in the gradient duration control. For Teledyne ISCO ReadySub C18 flash columns, the calibration compound elutes at 50% solvent. The first eluting compound retention time is used for methanol, and use the second compound for acetylnitrile when using Universal Test Mix. Click the Enabled button to add the HPLC option to the column menus. With the external HPLC calibrated and enabled, column selection has a new menu item. Run a compound mixture on a matching analytical column to your flash column. Select the desired column and select HPLC focus. Enter the retention time in the HPLC focus window and select the loading type. Run your sample as described using the NextGen scouting gradient. Here is an example of a calculated gradient from a UHPLC. Vanillin eluted at 3.087 minutes. After selecting a column, the HPLC focus button is selected. 3.087 minutes is entered as the retention time as well as the amount of silica in the solid load cartridge, and pressing OK calculates a gradient that can be run. Although you can get reasonable results from most analytical reverse phase columns, they aren't all the same. Differing C18 columns have different selectivity and retention time. All of these columns have the same column bed dimensions and will run with the same scouting gradient method. All columns use peak 4 to calibrate the scouting gradient, so the calculated gradient is the same for all of them for this compound. But as the compound eluted earlier in the scouting gradient, there was a larger difference between the gradient that would run on the flash system and the calculated gradients that would not run. The Agilent column retention times came the closest to the Teledyne ISCO column for the compounds tested, but the retention wasn't the same, and so the compound would not elute at the correct time in the focus gradient. The other columns gave useful gradients for only some of the compounds. Only the Teledyne ISCO column provided data that allowed correct calculated gradients in Teledyne ISCO flash columns. On the TLC plates, we can determine the loading by the difference in column volume elution between the compound to be purified and the nearest impurity. Remember that CV is 1 over the RF. If a delta CV is 1, that suggests the loading is around 1%. For scouting runs, this corresponds to a delta percent B of 3% in the scouting gradient. A delta percent B of around 32% allows 10% loading. I use delta percent B since it is easily determined with any scouting gradient. Loading capacity assumes well-behaved compounds with good peak shape. Peak shape affects loading. The top run used reverse phase with water and methanol. It is a successful run because the desired peak ran within the gradient. Adding 0.1% TFA to both solvents improved the peak shape and resolution. With more resolution, more sample can be run. If you need to add a buffer or modifier, run the scout gradient again because retention often changes, especially for ionizable compounds. One way to load C18 columns is to use silica cartridges. They work as guard columns to capture material that would stick to the C18 columns as shown on the picture on the right. Once a gradient has been calculated, use manual control to fill the cartridge with the starting solvent composition. Inject the sample into the cartridge. The table in this slide indicates the volume of liquid that can be loaded. This volume is up to half the volume that the cartridge can hold, so this is a conservative loading to avoid sample loss by the sample coming out the other end of the solid load cartridge. After loading the sample, install the solid load cartridge on the system and then run with the injection option solid load. You may find us on the social media sites listed here, and I want to thank you for your time today. Do you have any questions?
Well, thank you, Josh, or Jack, for sharing your expertise. And just to draw your attention, we have provided the QR codes for our social media and YouTube. So please, if you would scan that, you then can begin following us and keep up with the latest. With that, I'll turn it over to Jack to answer any of your questions.
And our first question is, why would we want to use an amine column? The reason for that column is it's good for acid-sensitive compounds. And also there's less need to use a basic modifier because the column itself is basic in nature. The next question is, can I use normal phase HPLC to calculate a focused gradient in Flash? The answer is yes, provided that you use the same, you dedicate your HPLC silica column to the same solvent systems that you use on Flash. I see, is there a way to transfer a reverse phase analytical method to normal phase flash chromatography? And the answer to that is no, not really. The reason for that is that the compounds have very, very different selectivity. And so as an example, if you run a mixture of parabens, methyl ethyl propyl butyl paraben on reverse phase, you see that they separate very well, but they come out all at the same time on silica gel. So that's one reason why we created this technique, is that you can run a small silica column and get a method for your compound. Thank you. We will check whether we have this feature on our NextGen and let you know. I can tell you that you don't yet have this feature on your NextGen, and we hope to release it no later than the end of April and probably sooner than that. Does each run need a new column? Are columns reusable? The reverse phase columns and the amine columns are definitely reusable, and you can run those. There's some customers who tend to try to reuse the columns by flushing them out with 2-propanol and storing them. And the problem with that is that the 2-propanol is a strong solvent and the column has a memory effect. So what happens is that when you reuse the column, the peak retentions change between runs. And so you get a run with a retention time in the scouting run, but when you try to reuse the column for your prep run, you find that the column, the peak has moved off from where you expect it to because the column is still equilibrating and getting rid of the 2-propanol. We have a blog up on our website that talks about this, although it's not specific for the focused gradient generator.
Well, we'll leave it open for just a while longer in case there are any other questions that are being typed in.
Yep. Another question is at the end, you talked about using silica gel cartridges for reverse phase. Could you explain that again? And the details are that the solvents used for reverse phase are strong solvents when run on silica gel. So the compounds come off the silica gel very easily, except for material that would be irreversibly retained. So the silica cartridge still acts like a guard column. Another question is, suppose that you calibrated your analytical HPLC with methanol. Can I use acetonitrile? And the answer is yes, you can, and you do not need to recalibrate. All the change in this to acetonitrile does is it affects the retention time on your column on your scout run. And so we pick that up in the retention time on the scout run and still calculate a focus gradient when you run acetonitrile on your flash system. Remember, we had an example where we ran the sample with 0.1% TFA, and we could calculate the gradient despite the change in solvents.